Solving LeetCode number 61, rotate list. Ever felt puzzled by LeetCode problem number 61, rotate list? Let's explore an easy-to-understand Python approach, working step by step through every detail, ensuring you grasp the logic and master solving this coding question easily. Let's first clearly understand the problem. We have a linked list, and we need to rotate its nodes to the right by k steps. For example, if we have a linked list 1, 2, 3, 4, 5, and we rotate it by 2 positions, the output should become 4, 5, 1, 2. Similarly, considering example 2 with 0, 1, 2, if we rotate it by 4 positions, we end up with a list 2, 0, 1. Notice rotating by 4 steps actually means 1 full rotation plus 1 extra step because the length of the list is 3. Now, let's see how we approach the solution step by step in Python, clearly and logically. Before coding our rotation logic, let's create the helper class list node, as this is required by LeetCode for singly linked list problems. Also, let's define a handy utility function, createLinkedList, to easily create our linked list from a regular Python list. This utility function creates a dummy node initially, then traverses through the list of integers, creating nodes sequentially and linking them. This setup will help us in quickly testing our example cases, converting human-readable lists into actual linked structures that our function operates on. Once this setup is done, we'll tackle the main problem next. Let's now dive into the main logic of rotating the linked list. First, we check if the list is empty or only has one node. If so, we simply return the head because rotating wouldn't make a difference. Then we calculate the length of our list and move to the last node. We connect this last node to our initial head, creating a circular list to simplify rotations. After that, we calculate effective rotations needed by using modulo with length. This step is crucial as rotating length times results in the original configuration. Then we identify the new tail, which will be length minus k steps from the head. The next node of this new tail will be our new head. We then break the cycle by setting the new tail's next pointer to none. Finally, we return the new head of our rotated list. Now, let's test our solution using the example provided in the problem description. We define another handy helper function called LinkedListToList to easily visualize the results by converting our linked list back into regular Python lists. By creating a linked list, 1, 2, 3, 4, 5, and rotating it by 2 steps, we should see 4, 5, 1, 2, 3 as the output. Using these helper functions makes our testing and debugging process significantly easier and quicker. As you see from the output, our implementation works perfectly fine. Testing our solution like this ensures correctness and reliability, crucial steps for any serious coding problem solver. Finally, let's discuss the time and space complexity. The time complexity of our solution is O(n) as we traverse the linked list twice, first to get its length and second to locate the new tail and head nodes. Here, n represents the number of nodes in the linked list. For the space complexity, our solution is O(1). The algorithm we have implemented is in place, meaning that we didn't use any extra storage or data structures to achieve the rotation. This makes our solution very efficient and optimal in terms of both time-space complexity. Hence, we have a highly efficient solution for solving LeetCode's rotate list problem, and understanding these complexities are crucial for assessing solutions. Congratulations! You've successfully learned how to confidently solve LeetCode number 61, rotate list. By using this logical approach, you can solve similar problems efficiently and confidently. Keep practicing and mastering these essential techniques for interviewing success and becoming a confident programmer.